क्वेश्चन नंबर 8 आज आपण पाहणार आहोत. For the sequence, if Sn is equal to 2 into 3 raised to n minus 1, find the nth term. Hence, show that the sequence is a GP. At first, we want to find out the nth term of this sequence. For that, you know the Tn is the nth term, and therefore Tn is equal to Sn minus 1. Therefore, given Sn is equal to 2 into 3 raised to n minus 1, then Sn minus 1 is equal to 2 into 3 raised to n minus 1 minus 1. Therefore, Tn is equal to Sn minus 1. This is the form. Therefore, we take their values. 2 into 3 raised to n minus 1 minus 2 into 3 raised to n minus 1 minus 1. Here 2 is common. 2 is common. And then 3n minus 1 minus 3n into 3 raised to minus 1. That is n plus minus 1. That is n minus 1. We also write 3 raised to n minus 1 is in the form, and here is minus plus 1. Therefore, plus 1 minus 1 will be cancelled. Now here 3n is common. Therefore, we get 2 into 3 raised to n is equal to 1 minus 1 upon 3. 3 raised to minus 1, that is equal to 1 upon 3. Therefore, we get here 2 into 3 raised to n into bracket, that is 3 minus 1, 2 upon 3. Therefore, we get here 4 upon 3 into 3 raised to n. This is the nth term of this sequence. Now we want to find out this is a sequence of geometric progression. Therefore, we take here Tn minus 1. Then we get 4 upon 3 into 3 raised to n minus 1. Here we put the value of n is n minus 1. Then change of n replaced by n minus 1. Now, you know about this. Next term, divide by first before term, that is r is equal to Tn upon Tn minus 1. This is the formula for finding the ratio. That is, we get here 4 upon 3 into 3 raised to n upon 4 upon 3 into 3 raised to n minus 1. Therefore, this is cancelled. Then we get here 3 raised to n minus base is same. Therefore, their powers are subtract from division. Now here n minus n will be cancelled. Therefore, we get here only 3. Hence, a sequence is GP. And complete the answer of this question. Now we take the next question, question number 9. Question number 9 is, if SPR are some product and sum of the reciprocals of n terms of n terms of GP respectively, then verify that S upon R bracket raised to n is equal to P square is equal to P square. For that, this is the sequence of GP. Therefore, yes, let GP A AR square AR raised to n minus 1 or next step is AR raised to n. Now, yes is their sum. Therefore, A plus AR plus AR square plus that dash plus A raised to n minus 1. Now here A is common. Then 1 plus R square plus that dash plus here R raised to n minus 1. For this sequence, you know that here is ratio is R and first term is 1. Therefore, we get S is equal to A into 1. A into 1 means A into R raised to n minus 1 upon R minus 1. This is equation number 1. Now, P is equal to product of these terms. Therefore, here is A is continuously multiplied at n times. Therefore, A raised to n, and here is 1 into R square into that dash into R raised to n minus. This sequence is also written in the form of what is this? Therefore, R raised to n into n minus 1 upon 2. This is the formula for this multiply or product of this sequence. Now, here we put S and then we get P product. Now, we take R 1 upon A plus 1 upon AR plus 1 upon AR square plus that dash plus 1 upon A into R raised to n minus 1. Therefore, here we get A is common. 1 upon A is common. Therefore, we get or here we put R raised to n minus 1. R raised to n minus 1. R raised to n minus 1 is the greater term of this sequence. Therefore, we get here R raised to n minus 1. Then here R raised to n minus 2. Then R raised to n minus 3. So on. Plus R square plus R plus 1. This is the addition of this term by calculating the LCM. Now, here this sequence is also written in the ascending form. Therefore, we get here This type of numerator can be written in the ascending form. Therefore, we get here the sequence is also written here. The first equation, that is what is the numerator? R raised to n minus 1 upon r minus 1. This type of sequence is getting from this numerator. Now here we take their values. What is this? For that we take r raised to n minus 1 and n. Here is a is multiplied and divided in this term. Therefore, we get the first equation in this equation, that is a square 1 upon a square n minus 1 into a into r raised to n minus 1 upon r minus 1. In this step, we have multiplied and divided by a. Therefore, we get this term, and this bracket is the equation of first, that is r equal to s upon a square into r raised to n. That is here this is denominator is multiplied here and r is divided here. Therefore, that is s upon r is equal to a square r raised to n minus 1. S upon r, we find their values. Therefore, S upon r bracket raised to n is equal to a raised to 2n into r raised to n minus 1 n into n minus 1. This is equation number 3, or this is the LHS of this part. Then after we want p square. What is p square? Now p square is equal to a raised to n into r raised to n into n minus 1 upon 2 bracket square. Therefore, squaring this, we get p square is equal to a raised to 2n, n square, a raised to n bracket square, that is a raised to 2n, and here is r raised to 2n into n minus 1 upon 2. Therefore, 2 get cancelled, and we get here equation number 4. Therefore, from 3 and 4, s upon r bracket raised to n is equal to p square. This is the answer of this question. Very easy questions. At first you take sum, then you take product, and in product you have know that there is a formula of this sequence of multiplication. Now after that s and p we getting, then we put the r, and here is by formula we get r, therefore s upon r, and then their power is n, therefore we get equation number 3. After that we taking equation p value is p square, and then therefore we get next number 10, example number 10. If Sn, S2n, S3n are the sum of n, 2n, 3n terms of GP respectively, then then verify that Sn into S3n minus S2n is equal to S2n minus Sn bracket square. For that, here we take the formula of Sn. Let Sn is equal to A into R raised to n upon R minus 1. This is the formula. Next, if we put the value of n is 2n, therefore we get a into r raised to 2n minus 1 upon r minus 1, and similarly s3n is equal to a into r raised to 3n minus 1 upon r minus 1. Now we solve the LHS. Let S3n minus Sn is equal to, put their values, a to r raised to 3n minus 1 upon r minus 1 minus a r raised to 2n minus 1 upon r minus 1. Therefore, a upon r minus 1 is common, and then in bracket r raised to 3n minus 1 minus r raised to 2n minus minus plus 1. Therefore, minus 1 plus 1 will be cancelled. Then we get r raised to 3n minus r raised to 2n, that is s3n minus sn is equal to a upon r minus 1 in bracket r raised to 2n into r raised to n, that is 2n plus 1 is 3n minus r raised to 2n, that is a into r raised to 2n is common from this bracket upon r minus 1 into r raised to n minus 1. This is the solution of s3n minus s2n. Now we take multiply by Sn. LHS equal to Sn into S3n minus S2n. S2n, here is S2n. Therefore, is equal to A into R raised to n minus 1 upon R minus 1 into A R raised to 2n upon R minus 1 into R raised to n minus 1. Now here A is multiplied by A, therefore A square, and then we get here R raised to 2n into A square into R raised to n minus 1 bracket square upon R minus 1 bracket square. This is the LHS. Now put the RHS. Let S2n minus Sn is equal to A R raised to 2n minus 1 upon R minus 1 minus A into R raised to n minus 1 upon R minus 1. Put their values of S2n and Sn. Therefore, here is A and R minus 1 is common, that is, and into bracket R raised to 2n minus 1 minus r raised to n plus 1 minus minus plus 1 minus 1 plus 1 cancel. Therefore r raised to 2n is also written as r raised to n into r raised to n, that is n plus n is 2n. Therefore here we get r raised to n into r raised to n. 2n is written as r raised to 2n is written in the form of r raised to n into r raised to n minus r raised to n. Therefore r raised to n take common, a into r raised to n into bracket r raised to n minus 1 upon r minus 1. Now LHS is complete. Then after we take RHS is equal to S to n minus Sn bracket square is equal to a square into r raised to 2n, then r raised to n minus 1 bracket square upon r minus 1 bracket square. Therefore LHS and RHS is same. Therefore LHS equal to RHS. LHS equal to RHS. Hence proved. Now we take the next three examples in next video.